Okay, 1.3 is called modeling with linear functions. Okay, so I'm going to talk about slope first. So the slope of a line describes how tilted it is, the angle that it's at. So these are supposed to be fraction bars here. Slope, we often use lowercase m for slope. And slope, you can think of it as the rise over the run. Okay, and if you're talking about rise, you're talking about how far, if you take, say, the ends of my pen here are points on this line, the rise would be how far up you go to get from one point to the other. So that's going to be determined by the y coordinates of these 2 points. So it's the difference of the y. So you can also think of this as one of your y coordinates minus the other one. So I wrote that as y sub 2 minus y sub 1. And then your run is how far left and right you would go to get from one point to the other. So I would go, right here some amount. So that's going to be dependent on the x values. So the run is the difference of the x values. And that gives me my slope formula, okay? So if I have a graph and I need to find the slope of a line, often I'll use rise over run and just kind of count the spaces. But when we don't have a graph, I would usually use the formula. You could graph these points and then just kind of count the rise and the run, but that seems to me to be more trouble than it's worth. So what I'm going to do, I'm going to think about 3, 8 as my first xy pair and 5, 2 as my second xy pair, and I'll use this formula right here. Okay, so I'm going to subtract the y's in the numerator. So let's see, 2 minus 8. And I'll subtract the x's in the denominator, so 5 minus 3. And you could have done 8 minus 2 and 3 minus 5, so you could have subtracted in that direction, and that would work out, but you just want to be consistent with the direction that you're subtracting in the numerator and denominator. Okay, so let's see, 2 minus 8 is negative 6, 5 minus 3 is 2, and that's going to simplify to negative 3, so the slope of that line would be negative 3. Okay. All right, let's try another. So I'm going to use the slope formula again. I'm going to subtract my y's, negative 8 minus negative 2, and then negative 5. Sorry, it was negative 8 minus negative 3. Whoops. Subtracting the y's on top. The x's, negative 5 minus negative 2. Okay, so I've got double negatives here, and that means I'm going to have to think of the double negatives as positives, right? Okay, so negative 8 plus 3 is negative 5. Negative 5 plus 2 is negative 3. And then a negative over a negative is going to come out positive, so I get positive 5/3. And you do want to make sure your answers are reduced there. Okay. All right. So slope-intercept form of an equation is going to look like this. Y equals mx plus b, where this would be the slope. And then the b is going to be the y-intercept. Okay? So if you have an equation that's in slope-intercept form like these two are, it's the easiest way, I think, to graph equations is when they're in this format. So I usually start with the y-intercept. So that means my line here is going to cross the y-axis at 4. So I'll count up 1, 2, 3, 4. That's where my line crosses the y-axis. And then my slope is 2/5. So that means I'm just thinking rise over run. So from this point, I can use the slope to get to any other point on the line. So I'm going to go, the top is the rise, so I'm going to go up 2 and then to the right 5. Up 2 to the right 5. 1, 2, 3. That up 2 to the right 5 is going to put me there, right? I went up 2 and then to the right 5. And that's all I really need to draw the line, because I can just connect the dots and draw my line. You could also plot another point. You could go up 2 to the right 5 again, although I'd be off my graph. But I can also go down 2 to the left 5, because negative 2 over negative 5 is equivalent to that, right? So I can go down 2 to the left 5. That'll put me there. And those line up, and then I can draw my line. There we go. And make sure it's not a line segment. It's a line that goes on infinitely in both directions. Okay. All right. So y-intercept here is 3. There it is. And then I'm using my slope, which is negative 1/2. And so you can think of this as -1 over 2, or you could think of it as 1 over -2. Those are all equivalent. So let's say I'm going -1 over 2. That means I go down 1 to the right 2. Or if I did +1 over 2, I'd go up 1 to the left 2. Okay, and it's worth noting that when you have a negative slope, the line is going to go downhill from left to right. When you have a positive slope, it's going to go uphill. That's worth knowing, because it's a nice way to check to make sure you didn't make mistakes. Okay, so let's do this in the opposite direction then. We're going to now write an equation in slope-intercept form. So this is y equals mx plus b. Okay, so all I really need then to write an equation is the slope and the y-intercept. All right, so let's see. Find my y-intercept here on this first one. So that means b is going to be -2. Okay, and then I'm going to find another point that's on the grid. You know, you could use like this point. I guess it looks like it's 1/2 0, but I like to find a coordinate pair that's integer, so that it looks like it's right on the grid, which to me that one looks like a good choice. Okay, and then I could use the coordinate pairs and do the slope formula, but it's much easier to just think rise over run. So I'm thinking, okay, I would go up 4 units and then to the right 1 unit. So that means my slope is going to be up 4 over 1. That would reduce to just 4. And now I've got the two things that I need. So I'm thinking y equals mx plus b. That means y equals 4x minus 2. And there's my equation in slope-intercept form. Okay. All right, let's try another here on this next one. So y-intercept here is 2. That means b is going to be 2. And let's choose another point. There's lots of them here that I could use. So here I'm going up 2 to the right 2. And that means the slope is going to be 1. So then I'm plugging the slope and the y-intercept into this. So it's going to be 1x plus 2, or just x plus 2. Right? You don't need to write the 1 because we can see there's 1x there. But it's not wrong if you wrote it. Okay. Okay. Next page, we're going to look at equations for these lines. So we've got a horizontal line here that we're going to write the equation for, and a vertical line here. Okay, so just to be clear about what line I'm talking about. All right, so one of these is going to be an x equals line, and the other is a y equals line, and often people get them confused. Okay, so here's how you can do it. With if you look at the ordered pairs, I've got, if you think about all of those points, okay, I'm just choosing a few random points on this line. Well, let's think about the coordinates of those points. I've got 0, -2. I've got 1, -2. I've got 2, -2. And then when you look at what all these points have in common, and any point on this line would have in common, the y's equal -2. Okay? And that means this is the equation y equals -2. Any point on that line has a y coordinate of -2. A lot of times I see people say, oh, this is x equals -2, but it's not. It's y equals -2. Okay? So if you forget which is which, just look at a couple of the ordered pairs, see what they have in common, and that will give it away. So let's use that same strategy here. If I'm looking and I'm just choosing random points here, if I look at these points, I've got -1, 4, I've got -1, 2, and -1, -3. Well, those have the x in common. The x for all of those points is -1. Okay? So y equals lines are horizontal, x equals lines are vertical. You can memorize that, but people mix them up. So if you forget, just look at a couple of the points. Okay? All right. Let's write the slope-intercept form of the equation for a line through the given point with the given slope. Okay, so we've got a through point here. Our line goes through this point, and we've got this slope. So if we're thinking y equals mx plus b, because that's what how they asked us to write the equation. Well, I already know the slope, so that's a good thing. But I still need to find the y-intercept. Okay. A lot of times I'll see people just choose one of those points as the y-intercept, and you might get lucky like that, but that is not really going to work. Okay. So what we want to do is use this xy pair that's given to us for our through point. So that little xy pair, what I'm going to do is plug that in to this equation for x and y. Okay, so I'm going to plug in those two bits. So I'm going to put in 5 for y and -1 for x. And now I've got an equation that I can solve for b. I can figure out what the b is, right? Because I already know it's going to be y equals 5x plus or minus something. I just need to figure out what that something is. So let's see, 5 times -1 is -5. And then I'm going to add 5 to both sides to isolate the b. And now I know what the b is, right? So now I can take this and say, okay, it's going to be y equals 5x plus 10. Okay, so basic strategy there. Plug in your slope first, then plug in your through point, and then you can find the y-intercept. So let's try it again here. So I'm starting with y equals mx plus b. I already know the m is -4. Okay, and now I'll plug in the xy pair into that slot. Make sure you don't mix them up. So the 2 would go right here. The -1 would go here. And I've got 2 equals 4 plus b then. And I'll subtract 4 from both sides. So -2 is going to equal b. And now I knew it was y equals -4x plus or minus something. Now I know it's y equals -4x minus 2. Okay. All right. So that brings us to point slope form. We've been using slope intercept, y equals mx plus b, but we've also got point slope form, which is going to look like this. Okay. So m is still the slope, but we have our new feature, which is the x1, y1. Well, that's going to refer to a through point. So my through point is going to be x sub 1, y sub 1. So my line would go through that xy pair, whatever it is. Okay. All right. So point slope form can be handy when you've gotten a situation like this where you have two through points. So I need to find the slope. You always need the slope to write an equation of a line, whether you're using slope intercept or point slope, or pretty much always. I guess there's some exceptions. But let's find the slope here. So I'm going to use the slope formula. Okay, I'm going to subtract the y's in the numerator, so 5 minus 3. And I'll subtract the x's in the denominator, 4 minus 2. Okay, so my slope is 1. All right. So let's see what we got. If we're using this formula right here, I'll just write it again here. Well, now I can plug in the 1 here, okay? So actually that would look the same without the 1, right? Since it's just multiplying by 1 there. But I do want to leave the parentheses, okay? And so the other thing I need is y sub 1 and x sub 1. Well, that's just any xy pair that is for any point that is on the line. And I've got 2 of them to choose from. So I know I labeled this one x1, y1, but it's just an xy pair. So I could use actually either one of these. For me personally, in my classes, I always just use the first of the xy pairs, but you could use either one of these. So there's 2 answers that would be correct. Okay, so if you plug in, let's plug in this first pair. I'm plugging in 3 for y sub 1. And then I'll plug in 2 for x sub 1. And yeah, you don't really need the 1 there, but I'm just leaving it there so it's in point slope form. Okay, but I also could have put in the other xy pair. Whoops, my other xy pair, the y is 5. Sorry, I got carried away there. My slope was still 1, and the other x was 4. Okay, and if you ended up with double negatives, you wouldn't want to leave the double negatives in your final answer. Okay, So if you put these both in slope-intercept form, they would actually be equivalent to each other. So they're both correct. All right. So let's try another one here. I'm going to find the slope first using the slope formula. So let's see, subtracting the y's, -2 minus 0 in my numerator. Denominator, 2 minus -1, subtracting my x's. So on top I got -2. On bottom that would be 2 plus 1 for 3. So my slope is -2/3. Okay. And then I'm going to start plugging into the point slope form formula. Okay. I'm going to need to plug in 3 different things. I'm going to put them in all at once this time. Okay. So I'm plugging in the slope, which I just found out, but I'm also plugging in one of the xy pairs, and I'm going to use this one here. Okay, so my y sub 1 is 0, slope is -2/3, and then x minus -1. Okay, and just to clean this up a little bit, you don't really need the -0 because it doesn't do anything. And then we wouldn't want to leave a double negative in our answer. Okay. Just real quick, to do the other version, it would be y minus this, so it would end up with be y minus -2, that'd be a positive 2 then, right? I still have -2/3, and then x minus 2. So this is another solution that is correct. Okay, let's look at some word problems, some applications, I guess sort of word problems. So here we've got a pizza joint called Pizza World, and then it has the number of pizzas you order and what the cost would be. So, you know, if you're ordering one pizza, that's going to cost $25 to get it delivered. If you order 2 pizzas, it's $45 and so forth. Okay. So, all right. So this is a line, a straight line, right? So let's find the slope of the line. So I'm going to use, you can use rise over run, but you want to be careful because each tick is not 1 unit, right? So when you're looking at your y's, each tick there is 5 units actually if you look closely. So just to be safe, I'm going to just use the xy pairs that are labeled here, okay? So I'm going to subtract the y's in the numerator and the x's in the denominator. So then 45 minus 25 is 20, and 2 minus 1 is 1, so my slope is 20. Okay, now let's write an equation in slope-intercept form. So that would be y equals mx plus b. All right, so we already know that the slope is 20, and now we need the y-intercept, and you can see just by looking, the y-intercept would be 5. It appears to be 5. Whoops, I just wrote B. So if you get 0 pizzas delivered, that still costs $5 for someone to drive to your house and give you an empty box, I guess. Okay. All right. So how much would it cost to get 11 pizzas delivered? Well, this, you know, on this graph we can see up to about 5 pizzas, or actually you only can see the ordered pairs up to 4. So this is going to be off the graph somewhere. But we can use the equation. Okay, so if you think about the number of pizzas, these are our x values, right? Because this is on the x axis, and then the delivery cost would be the y's. All right, so what we can do is take this equation and plug in 11 for our x value. That represents 11 pizzas. So I guess each pizza costs $20, but then there's a $5 delivery fee. Okay, so then I've got 20 times 11, which is 220. And then, so this would cost $225 to get 11 pizzas delivered. Okay, this one says how many pizzas could you afford to have delivered with $285. Okay, so this time this is going to be the y because that's the cost. We know what the cost is already, we just don't know how many pizzas we get. All right, so we're still going to use this equation that we wrote, but this time we're plugging in 285 here, and we want to solve this for x. So I'm going to subtract 5 from both sides, so now I've got 280 equals 20x, and then I'll divide by 20. And that's going to give me 14. So this would be 14 pizzas. Okay. All right, let's try another one. So this one, there's no graph. This is a competing restaurant, Pizza Galaxy. Okay, so we don't have a graph, but we have this, this table here. It says find the slope of a line that would fit these data points. So you could graph these, but I'm not going to do that. So just think of these as XY pairs. Okay, and if you have just two XY pairs, then you can find the slope. So, you know, we can think of this as 241, and this would be 123. So I'm going to use the slope formula. I'm going to subtract the y's in the numerator, and I'll subtract the x's in the denominator. Okay, so then I've got 18 over 1. So the slope then would be 18. And from using that slope, now we can write an equation. So thinking y equals mx plus b. Well, I know that the slope is 18. Okay, and now what I want to do to find the b, so it's going to be y equals 18x plus or minus something. To find that something, I'm going to plug in one of my xy pairs. I've got a bunch of them to choose from. I'll just use 123. So I'm going to put 23 in for y, 1 in for x, and then I can solve this for b. Okay, so this is 23 equals 18 plus b. I'm just going to subtract 18 from both sides. I'm running out of space there. But my b would be 5. So now y equals 18x plus 5. Okay, and now I can use that equation to figure out any question they ask me. So now they're asking how much would 17 pizzas cost. So I got to think, is 17 my x or my y? That's the number of pizzas. Well, if you look at the table, that's the x value, right? So I'm going to plug in 17 right here. Let's see, 18 times 17 is 306. And then, so it's going to be $311 for 17 pizzas from Pizza Galaxy. Okay. All right. So let's take a look at a graphing calculator. I'm going to use a TI 84 here, but this would work the same on a TI 83 or on a lot of different TIs. Okay, trying to find a good spot for that. We're going to use a graphing calculator, and we're going to write an equation. I mean, we already have an equation here, but let's try this out using this data table. Okay, and here are the basic things you want to do. So we want to find the stat button on the calculator, which is near the top middle here. Okay, so I'm hitting stat, and then I'm going to choose edit. Well, the first column there is edit, but then the first choice in that column is edit, so I'm going to hit enter. Okay, I've got some stuff in here already, which I want to clear out. You can actually write right on top of those data points. And you can hit clear and enter on each one of those entries, but if you go to the top and highlight L1, I'm going to hit clear and enter, and that'll clear out the whole column there. And I'll do the same thing with L2. This is list 1, list 2. I'm going to use list 1 as my X's and list 2 as my Y's. Okay? So then I'm going to go, I'm going to enter all this data in here. So my X's would be 1, 2, 3, 4, 5, 6. So I'm going to hit 1, and then the 1 just shows up at the bottom of the screen, but if I hit enter, then it's in the table. Or you can hit, when you hit 2, you can just scroll down and then it'll be in there. I just hit enter after every thing because then I can type them in quickly. Okay, and then I'm just going to scroll over to my Y's. And I'm typing in all of those Y's. So you want to make sure you don't have anything in the other lists, and also make sure you have the same amount of x's as y's. If you have a different number of them, it's going to mess this up. Okay, so I got all of that data now stored in my calculator. Okay, and now I'm going to go back to the stat menu again. So I'll hit that stat button again, and this time I'm going to go to the calc column. So there's no calc choice here, but at the top I can scroll over the calc, and I'm going to go down. I'm going to do what's called a linear regression. So you see this fourth choice here, linear regression. I know this is going to fit a straight line. That's why I'm doing a linear regression. But if you knew like your data would fit a parabola, then you'd want to do a quadratic regression and so forth. Okay, so I'm going to choose this button, linear regression. I won't write the rest of it, but that's the one we want to choose. I'm going to hit enter. Okay, it's going to ask me which list to use. I'm using L1 and L2, so I'm just hitting enter twice to get past this. Some of your calculators, it might not have the screen at all. I'm just hitting enter, enter, enter until I get down to calculate, or you can just scroll down there. And then now it's, when I say calculate, it's giving me the equation. So it tells me it's giving the equation y equals, it calls it y equals ax plus b form. But then it tells me what the a and the b are, right? It says a is 18, b is 5, which is exactly what we got when we wrote the equation. But you can also do that with technology like so. Okay, let's look at a scatter plot on the next page. So here's a scatter plot. We've got shoe sizes here and heights. So, as your shoe size gets bigger, in general, your height gets bigger. So you could say that these points have a positive correlation because it kind of has this uphill line sort of trend. A line doesn't fit it exactly, but it kind of approximates it. Okay, if you had a negative correlation, then the points would fit a downhill line, a line with a negative slope. And if they're just random points all over the graph and you can't make a line fit at all, you could say that those things have no correlation or a very weak correlation. Okay. All right, so let's see. The following scatter plot, I already said that. Okay, that's 10 individuals there. All right, part A, sketch a line of best fit. So a line of best fit, you're just going to draw a line to fit the data as best you can. It's not a perfect science. You just want to get something that fits the data okay. So something like that. Everyone's going to draw it a little bit differently, but basically just try to get about the same number of points above the line as below. I got a little more below there, but something in that range. Okay. All right, part B, write an equation for this line using two ordered pairs that are on the line or very close to it. So I see I don't really have any of my ordered pairs right on this line, but it's pretty close to this one and this one. So I think I'll just use those two because I just sketched this in anyways. Okay, so I'm just finding two of the points that were really close to the line, and this is the point 560, and this would be the point, looks like 1272. So I'm going to use those two ordered pairs to write the equation. So I'm going to need the slope first. So I'll subtract the y's, 72 minus 60, and then I'll subtract the x's in the denominator, 12 minus 5. Okay, so let's see, I've got 12 over 7. So my slope is 12/7, okay? And then you could write this in point slope form, but I'm going to use slope intercept. So I'm thinking, okay, now I found the slope, and I just need to find the b. So what I'm going to do is use one of these ordered pairs. It doesn't matter which one. I'll use the 5 and the 60 just because they're smaller numbers. I'm going to plug 60 in here for y, and I'm going to plug 5 in for x. Okay, and this is going to be a little bit messy, but I can use this to find b. So let's see. 12 times 5 is 60, right? So I've got 60 over 7 plus b, okay? Now, I'm going to subtract 67ths from both sides, but I'm going to want a common denominator here. So I'm going to multiply this by 7 over 7, which is going to give me 420 over 7. Okay, so now I can subtract from both sides. let's see, I'm going to get 360 over 7 equals b. So my equation now, I can write it. I already, I'm just using this, except now I found the b, right? So now I can say y equals 12/7 x plus 360/7. Okay? And, depending on which ordered pair you used or how you drew your line of fit, you might get an answer that's slightly different. You could also use decimals here. I would leave your slope as a fraction, but maybe you want to write your y-intercept as a decimal. Okay? All right. So let's look at this next one. Here is the same data from the scatter plot above. Okay, so those are all the ordered pairs. And let's try to do this with a graphing calculator. So we can also make a graphing calculator do this. So what I want to do is enter the data just like I did on the last page first. So I'm going to go to the Stat menu, and I'll choose Edit. I've still got my old XY table in there, so I'm going to highlight L1, hit Clear and Enter. Same thing with L2. You could write right on top of it, but I like to just clear it out. And then I'm going to put in all of these X's. So 5, enter, 6, enter, 7, enter, so forth. Okay, and then I'll put in the Y's. Okay, and now I'm going to go to the Stat menu once I get it all entered in there. Okay. So just to get the steps down, we did Stat and then Edit to get the points all in there. And now I'm going to go to Stat, and I'm going to go over the Calc menu because I want to do some calculations with, so I went to the Calc column, and I'm going to go down and do a linear regression just like we did on the last page. Okay, and I'll just hit enter or scroll across the screen until you get to calculate. Okay, and then I've got this equation. And I'm going to round this a little bit, but it says that the A is about 1.73 and the B is about 51.01 or 51.02, I should say. Okay, and it's not the exact same as my last equation, my last answer there, but if you look at the decimal versions of these, it should be pretty close to it actually. Okay, all right, that's it for this section, and I'll see you next time.